Salam. Today we are discussing about Maclaurin series of different functions and keep watching video and don't skip if you want to learn about Maclaurin series. First of all, we check the function of e raised to power x. This is an exponential function and we want to find the Maclaurin series of that function. So we just need the requirement for Maclaurin series. We know that if f at x is equal to f at 0 plus f prime at 0 and here is x plus f double prime at 0 with x square over 2 factorial plus up to so on f triple prime at 0 x cube over 3 factorial plus f4 at 0 x power 4 over 4 factorial plus up to so on infinite, and we just follow the pattern of the functions at 0 and at the end we just put the values here in equation number 1. So we just know that if there is a function f at x, so f at 0 will be e power 0 which is equal to 1. Also we now find because f at 0 is cleared, now f prime at 0, for that we need the first derivative and that is e power x, second derivative that is also e raised to power x, and third derivative that is also e power x, and fourth derivative that is also x. And we can observe that uh, this will give us the answer at 0 will be 1 automatically. For second derivative at 0 will be 1, and for third derivative it will again 1, and for the fourth derivative it will again 1. So following this pattern, if we put in equation 1, so equation 1 becomes here f at x, no, we need just here f at x is equal to e raised to power x, so we just put e power x, and f at 0 is equal to 1, so 1. For f prime at 0 we know that 1, so no need to write anything. X for second derivative again 1 into x square time x square, and in fraction where there is 2 factorial, other notation is this, and moreover 1 1 1 can tell us that there is a product with 1, no need to write up to x4 over 4 factorial plus up to so on. So that is the final Maclaurin series of a exponential function e raised to power x. Now we are discussing about the Maclaurin series of, you can say, cos x. So you know that f at 0 means cos 0 will be 1, and we already discussed about the formula of that function. So we know that cos x Maclaurin series is equal to f at 0 plus f prime at 0 x plus f double prime at 0 x square over 2 factorial plus up to so on. Next f triple prime at 0 x cube over 3 factorial plus f4 factorial 4 into 4 at 0 x4 over 4 factorial, and you can see that according to requirement we just need to find the pattern of up to 3 to 4 functions derivative. So for that reason we just need to find the first derivative. You can observe that this is a function of fx, so if we write this or this. Basically this is the formula. So f prime x is equal to derivative of cos x is equal to minus sin x, and if we put 0 in that function we get answer 0. And if we take the second derivative of this function, then minus cos x will be the answer, and we get the second derivative at 0 will be minus 1, because cos 0 will be 1, and here minus 1 sign. F triple prime at x is equal to, you can see that minus minus cancel and sin x, and f triple prime at 0 gives the answer 0. So we can see that first answer will be 1, second will be 0, third will be 1, fourth one will be 0, and again last one we can check fourth derivative. Sin x is equal to cos x. This implies a fourth derivative at 0 will be, and cos x here is again cos x, and we get the answer 1. So that is the pattern: 1 0 minus 1 0 1 again 0 minus 1. So finally equation 1 becomes, that will be the equation 1 becomes, in left hand side there is a function of cos x, the Maclaurin series which we have required. Here f at 0 will be 1, f prime at 0 at x, multiply x will be 0, and f double prime at 0 will be minus 1, and into x square over 2 factorial, again after minus 1 0, and now for fourth derivative it will again 1 into x power 4 over 4 factorial plus up to so on. So we conclude that 1 minus x square over 2 factorial plus x4 over 4 factorial plus up to so on, that is the Maclaurin series for the trigonometric function cos of x. Hope so you can understand. Now the third one is trigonometric function sin of x. We can find the f at 0, which is equal to 0, and after that we just write up the formula of Maclaurin series, which is f at 0 plus f prime at 0 x plus f double prime at 0 x square over 2 factorial plus f triple prime at 0 x cube over 3 factorial plus up to so on, and that will be the equation number 1. Now we are going to find the derivatives: first derivative, second derivative, third derivative, fourth derivative, and up to so on. What we can observe that derivative of sin x is equal to cos x, and this is minus sin x, and again derivative will give us cos x, and again derivative will give us after sin to cos again sin x, plus sin x. So that's way, in that way we can find the pattern at 0. So f prime at 0 will be cos 0 1, and f double prime at 0 sin 0 will be 0, f triple prime at 0 cos 0 minus 1, because at start there is a symbol of minus or sign of minus, sin 0 0. So what we observe that 0 1 0 minus 1 0, again here 1. So in that way we can follow the pattern. So equation 1 becomes, we can put fx is equal to sin of x, and at 0 answer is 0, at first derivative answer is 1 into x, at second derivative answer is 0, and at third derivative answer is minus 1, and 3 factorial. In such pattern, fourth derivative is again 0 plus up to so on, and we just need to follow that one next time. X minus x cube over 3 factorial plus x3 up. Now you can observe that here is 1, here is 3, here is 5. In that way, with alternate sign, minus plus minus, x7 over 7 factorial plus x9 over 9 factorial. In that way series uh, going on. So hope so you can understand the Maclaurin series of sin x. Now we will discuss about the last one, 1 over 1 plus x series. So f(x) is equal to 1 over 1 plus x. You can easily observe that if we find at 0, f at 0 will be 1 over 1 plus 0 is equal to 1. And we already know the Maclaurin series of function fx is equal to f at 0 plus f prime at 0 into x plus f double prime at 0 x square over 2 factorial plus up to so on f 3 at 0 x cube over 3 factorial up to so on. Now we just need to find the requirements. F at 0 is already find, f prime at 0 needed. For that we find f derivative of x, f double derivative of x, f triple derivative of x, and f fourth derivative of x. In that pattern we find all the. Now first derivative we can see that that will be 1 plus x power minus 1. In that case we just find the power rule. Power rule will give us minus 1 over 1 plus x. At numerator power will be minus 2, and in denominator we get square. So that will be the, but we can find at 0. So when x will be 0, here 1 power square is already, we know that answer will be minus 1. So in that case again we uh, do that denominator power 2 in numerator, and minus 2 will be at start. So we get 2 over 1 plus x cube. So that will give us f double prime at 0 is equal to 2. And when we get third, because that plus sign will get at higher in numerator, and we can see that 2 multiply minus 3 into 1 plus x power minus 4. So it will give us 2 3 times minus 6 over 1 plus x whole power 4. And if we want to find the third derivative at 0, we get minus 6. So here we can observe that first one is positive, second one is negative, third one is positive, fourth one is negative, and at last we can see that 6 4 times 24, minus minus will be plus. So 24 over 1 plus x power 5, and answer will be f fourth derivative at 0 is equal to 24, again positive. So in that scenario we just observe that equation 1 becomes here function is 1 over 1 plus x. F at 0 is answer 1. F prime at 0 into x, we know that f prime at 0 is equal to minus 1. So here is alternate series x. Again for positive, second derivative is equal to 2, and you can easily observe that that is equal to 2 factorial also, and this is also if we get a negative sign as a power, we can observe that this is minus 3 factorial and this is a 4 factorial. Okay, so for second derivative we get 2 factorial and plus 2 factorial. Again in fraction we already have our factorial, so that 2 factorial is cancelled out with 2 factorial. And also for third derivative at 0 we observe that here is a minus 6, or you can say that minus into 3 factorial, and in denominator already 3 factorial and x cube as it is, plus up to so on here 4 factorial, x 4 over 4 factorial plus up to so on. So the final answer is 3 factorial cancel out, 4 factorial cancel out, we get the answer 1 minus x plus x square minus x cube plus x4. So alternatively this will goes up to infinite. So that is the Maclaurin series of 1 over 1 plus x. Hope so you can understand, and if you have any problem related to Maclaurin series, you can feel free to contact, and also you can comment and ask any question related to that topic. Thank you so much, keep watching my channel, and that is the motivation for me to make more videos and with zest and zeal work on it.